Examine the details, the tight carbon weave, the heat shimmer off the exhaust, zero-delay needle jumps. Most of the world's most powerful car companies required half a century to develop this level of engineering authority. This machine reached the same destination in a fraction of that time. The hypercar industry is built on legacy. Manufacturers like Ferrari and Porsche rely on massive development budgets, global infrastructures, and decades of racing history to validate their performance. Koenigsegg began in a different environment. No racing team, no massive factory, and no established network. Just a quiet space in the Swedish countryside. Christian von Koenigsegg didn't come from an automotive dynasty. He had a childhood ambition to build a supercar from a clean sheet of paper, rather than modifying what already existed. It raises a question. How does a startup with no pre-existing infrastructure out-engineer the most established titans in the automotive world? Christian was not bound by a specific lineage. This allowed him to evaluate the car's architecture based on performance requirements, rather than historical consistency. During the early development phase, the team avoided the industry standard of purchasing major components from larger suppliers. They chose to build their own. The CC8S was the first physical proof of this independence. It wasn't a kit car or a tuning project, it was a bespoke reality. This animation shows the mechanics of their dihedral synchrohelix door. The hinge mechanism pushes the door outward, sweeps it upward, and then rotates it vertically to clear the curb. Developing a proprietary hinge mechanism in-house required an investment in tooling and time that most small manufacturers avoid. It demonstrated a preference for internal mechanical solutions over existing, cheaper alternatives. The CCR marked the moment the company became a legitimate threat. It was a machine capable of challenging the world's top speed records. By internalizing their engineering processes, Koenigsegg demonstrated that a small team can produce performance data comparable to companies with 10 times the staff. In hypercar design, adding horsepower requires larger engines and complex cooling systems, adding weight. That extra mass limits stopping and turning capability. The Koenigsegg 11 was engineered to solve this. The goal: 1 horsepower per kilogram, 1,360 horsepower, driving a 1,360 kilogram car. To reach that equilibrium, engineers had to rethink every component. They used advanced carbon fiber techniques to strip away mass without sacrificing the structural rigidity required for those speeds. This obsession with weight and material science directly informed the development of the Agera RS. The Agera RS used this precise balance of aerodynamics and mass to eventually set a new production car speed record, clocked on a public highway. At this level of performance, managing the car's relationship with air and gravity is more significant than simply adding more engine power. Traditional gearboxes create a bottleneck. Every time a car shifts gears, there is a momentary interruption in power delivery to the wheels. For the Regera, Koenigsegg chose to bypass the transmission entirely. They didn't refine the gearbox, they removed it. This schematic shows the direct drive system. By connecting the engine and electric motors directly to the rear axle, they eliminated shift times, providing a continuous flow of torque from zero to top speed. This same willingness to rethink basic hardware led to the light-speed transmission and free valve, a system that controls engine valves using electronics rather than a mechanical camshaft. The company succeeds by questioning mechanical assumptions that the broader industry treats as fixed constraints. The CC850 is a modern machine, but it's designed to celebrate the tactile feeling of the company's earliest cars. It uses the Engage shift system, a complex digital architecture that simulates the feel of a traditional manual gear shifter. It's a high-tech solution to preserve an analog experience. A Koenigsegg owner isn't just buying speed, they are purchasing mechanical theater, a machine that values individuality over mass-market efficiency. In this market, the real value is in owning something that functions according to its own set of rules. As the industry shifts towards electrification, the role of high-performance engineering is changing. Koenigsegg's approach remains flexible. By combining combustion, software, and electric motors, they can adapt to whatever technology offers the highest performance. Because they are not anchored to a single legacy architecture, they can pivot to whatever method allows them to push the boundaries of speed. The company's focus remains on the math. Their ultimate goal is to find a point where engineering efficiency meets The theoretical limits of friction, weight, and air resistance.